Today we're gonna be doing integration by use substitution. So for sure, let me do this. So now we come into, this is our chapter 10, the methods of integration. So now we're gonna be focusing on 3 types of methods. The first one which is use substitution, second one by parts, third one by fraction. So now on use substitution, this says that in an integration process, they say that replacing a function by x or replacing a function of x by another variable may reduce the integral to one of the previous forms, and as a result simplify the work. So the idea behind using use substitution is to simplify the work. I'm sure we can say this, right? So for example, if we have this question A, they say we're given the integral of x plus 1 to the 20 dx. So they say let us set u to be x plus 1. Then now the idea behind this, if I come here and do this and I say, I'm given the integral of x plus 1 to the 20 dx. We know that according to how we're solving back then, if it was x to the 20, I would integrate this and say that this is x to the 20 plus 1 over 20 plus 1 plus c. So those who haven't written the L'Hopital rules tutorial, trust me, you're gonna be left behind. You won't have time. So what I'm gonna be doing from now on is I'll be giving you questions. So after when we are done here, I'll give you around I think I'll see maybe 10 questions based on use substitution, which are not even coming from your guide. So it means that I'm going to give you 10 from outside your guide plus those that are coming from your guide. So you must do all of them. So if you're going to be left behind, if you're not going to pull up your socks. So this would be x 21 over 21 plus c. Now for this idea, we could also do the same thing when we come to this one. We would say x plus 1 to the 20 over 20 plus c. You see, right? Then I add 1 there, add 1 here. You see, then this would be x plus 1 to the 21 over 21. But we're not allowed to do this. We are only allowed to do this if this is one thing, it's one thing. So for us to solve that, to simplify that, you're gonna have this rule. I'm gonna show you this rule. The rules that we can use when applying integration. The rules that you have to use when applying integration is that when you're given an integral, look at this integral as you have two things. Like this one we have 1 and also we have x plus 1 to the 20 dx. For use substitution, you're always gonna have two functions. For those two functions, you're going to look at one function that is difficult to derive. Between 1 and this one is the one which is difficult to derive. We agree, right? So it means that what you're going to do, we are going to let u be equal to the inside. It's either the inside or the exponent of whatever that is difficult to derive. You see, right? I hope we agree on that. Whatever that is difficult to derive, you're going to make sure that you let u, it's like for example here, I'm going to let the inside of this, I let u be equal to x plus 1. Then I derive it. When I derive this, I get 1, so I'm going to multiply that by dx. I come back and substitute here. We know that x plus 1 is equal to u, so I'll have u 20, and then dx, that dx is equal to du, so I'll have du. Then when I integrate this, I would have what? This I would have u 20 plus 1 over 20 plus 1 plus c. And this would be u, 21 over 21 plus c. You see, right? Then now I come back to plug my u. My u is x plus 1, 21 over 21 plus c. Then that will be the solution. We see, right? Then we'll come to the second question. So we're just gonna go through this so we can write the exercises. Usually, yeah, but it's fine. So now when we come to this, what happens is that this function is in this format: 2x e to the x squared dx. You see, right? So what happens here is that I'm given two functions, this function and this function. Now, which one is difficult to derive? E to the x squared. You see, right? So I would let u be equals to e to the x squared. Then I derive this. When I derive e to the x squared, I keep e to the x squared times the derivative of the exponent, which would give us 2x times ln e times dx. You see, right? So this would be e to the x 2x dx. Then I make dx up with the formula out of du over e to the x 2x dx. Then I come back to substitute there. The integral of 2 integral of x e. So check, I want to show you something. This is u, right? I want to show you something. This would be du over a, this is 2x, e to the 2x. I want to show you this. This would cancel this. You see, we would be left with the integral of u a. Check this. You see that this, we still have a variable of x there, which is not applicable. So whenever after using your substitution, you find variable of x there, this tells you that you cannot use that rule. You see, right? So to solve this problem, instead of letting the whole question to be u, we are going to let only the exponent. You see, right? So we're going to let only the exponent. So now you'll understand why whenever we're dealing with this, we let the exponent or we let the inside. You see here, I had 1 and x plus 1 to the 20. I didn't let this whole thing to be u. If I did, I was going to have a problem. I only let it inside. You see, right? Then that's what's going to happen here. Instead of letting this whole thing to be u, I'm going to let the exponent of the difficult one to derive to be u. This is difficult to derive, so I let its exponent to be u. So now what will happen? I'll derive here. I get 2x multiplied by dx. You see, right? And then now what I'm going to do is I'm going to say that now I make du subject to the formula of 2x is equals to dx. You see, right? And then now I can go back and substitute. This will be the integral. This will be 2 is equals to integral of x e to the u, because we know that x squared is equals to u, right? Du over 2x. Now we know that x will cancel x, 2 will cancel 2. You see, right? And then this will be the integral of e to the u du. So when we integrate e to the u, we keep e to the u, we divide by the derivative of the exponent times ln base plus c. You see, right? And this would be e to the, our u is what? Our u is x squared. You see, right? So if we derive this u, we keep it like that. So we'd get this solution. That's why here, if you check on the solution, we have e to the x squared plus c. So Now we come to this one. Again, we look at two functions. One is difficult to derive, one is not. You see, right? And the one that is difficult to derive here, it's which one? Who can tell me which one is difficult to derive? Between 1 and 2, which one is difficult to derive? Two, right? So it means that now we are going to come and say we let u be equal to the inside of 2. You see, right? Then we derive. So we're gonna come and do this. We let, like this. We let u be equal to, x squared plus 5, right? Then when I derive this, I'm going to get 2x dx. I hope we agree on this. I'll get 2x dx. Then I make dx with the formula. You see, right? And this would be the integral of, when I go back, x root of u du over 2x. And this I'll take out the 1 over 2. The x cancels out. I'm left with u to the 1 over 2 du. That's why here I have this. Now if we go this side, let me erase this here. So I go that side and I show you. So what they did, they let u be equal to x squared plus 5. Then they derive, they get this. We make it dx with the formula, we get this. So this would mean that from here we come back and substitute. When we substitute, remember we got this, right? Because the x cancelled the x, we took out the 1 over 2. Then we got this. Then when we integrate this, we're going to have 1 over 2 u1 over 2 plus 1 over 1 over 2 plus 1. That is it. Then we add c. That's how we got this. You see, right? So the solution, we come back and plug our u. Do you agree on this? So always keep in mind, for u substitution, you always let it's either the inside, so I'll write the rules, right? It's either the inside of that function or the exponent of that function if it's e. So we come to d. D again, we only have one function, the other function is 1. So it means that this is the one which is difficult to derive. So we're gonna take this function, we let its inside be u. The inside is what? 6x. You see, right? We let its inside be u. So meaning that when we let the inside of this be u, we are going to say, so we are going to say that now I'll derive this. When I derive it, I'm going to have from here du is equal to 6 dx. You see, right? Then I make du substitute or dx with the formula, which I'll have this. If I divide both sides by 6. So we have this. Now I come back and say from here, this is u. So I can substitute u there, and dx is equal to this. You see, right? Then I can come and say now, I'll take out 1 over 6 as a constant. I'll take out 1 over 6 as a constant and show the integral of this. I'll just have 1 over 3 there plus 1 over 1 over 3 plus 1. We shall get this. You see, right? And then we simplify that. This times this would give us 1 over 8. So we substitute back our u. Now we come back again here. Between this and this, we realize that E is the one which is difficult to derive. So we're going to let the exponent of E be U. Then I derive, you see, right? I make the x out of the formula. Then I come back and plug. When I plug back, this will cancel this. I take out 1 over 3 as a constant. Then I integrate this E to the U. I get E to the U. You know, integrating E to the U will remain the same. Why? Because when I'm integrating E to the U, I say E to the U over ln E times the derivative of U plus C. You see, right? So I'll get E. And then after getting that E to the U, I come back and substitute my U. You see, right? Then that will be the case. So, meaning, now, if we come to this one, F we look at the numerator and denominator. The denominator is the one which is difficult to derive. You see, right? Denominator is the one which is difficult to derive. So I'll let the denominator be U, which is this. Is difficult to derive. I'll let that be U. Then I derive it. I get 4x to the third plus 6x. Then I make the x of the formula. So it means that when I derive this, I'll get 4x to the third plus 6x dx. I put brackets. So you must put both brackets because there's a plus in here. So I make the x of the formula. It means that I'll divide both sides by this. And when I look at this one is 2x to the third plus 3x. So it means that I must factor out 2 here. That's why they factored out 2 there on this one. You see, so that it can cancel out that one. So do you agree on this? So we substitute U here. Now we come and say, if I substitute dx, which is equal to this, now I know that, let me do this. I know that this one will cancel out with this one. You see, right? These will cancel out. So now it means that after when they cancel out, I'll be left with 1 over 2. I take it out as a constant, and the integral of 1 over U du. And we know that the integral of 1 over, if we have integral of this will be equal to ln of absolute value of that. Don't use ln of, you see, right? Use absolute value of that plus C. Then I come back and substitute that value. We say, right? So we get that. Then here they tell you that since this is greater than 0, for all x element of real numbers, how do we see that the exponents are positive? They're even, not positive, they're even. So this we can now change it to this if you want. But I want us to check that always. We're going to check that condition always. We're not dealing with ln. So we come to this one. We're having 2 functions. The first function is 1. The second one is sine. So I take sine because it's the one which is difficult to derive. I let its inside be U. Then I derive. I make the x of the formula. You see, right? Then I come and say this. Our U is this. Then our dx is du over 4. Then I'm going to come and take out 1 over 4. When I integrate sin U, remember, when you derive sin x, we are going to get positive cos x. This means that when I integrate now cos x, I must get sin x. You see, right? And when you derive negative cos x, you'll get positive sin x. This means when I integrate positive sine x, I must get negative cos x. You see, right? So with practice, you can remember this. You don't have to memorize, you can remember them. Because if you memorize, you get there, you'll forget. With too much practice, you can remember this. So now we see why for this one, sine u, we got the integral of sine u, we got negative cos u. You see, then I substitute back the u. You see right now? Now you see why. Then I come to this 2. I realize that the root of sine x is the one which is difficult to derive. So I'm going to let it inside the bu, which is sine x. You see, I derive it and make dx up with the formula. Then I come back to substitute. Our sine x is u. Then dx will be du over cos x. And then the cos x will cancel the cos x. Then I'm left with this one, u of to the exponent 1 over 2. Then I apply integration. You see that when I apply integration, I get this is equals to u to the 3 over 2 over 3 over 2 plus c. Then this will be equals to 2 over 3 sine x 3 over to the 3 over 2 plus c. You see, right? And then this is what I get. Now let's come here. Yeah, I'm just gonna give you hints, right? You're gonna solve this. How many are they? 10, right? I'm gonna give you another 10 based on your substitution. So I'll give you another 10 based on your substitution. You shall note for a hint, I'm going to underline the ones that have the difficult function to derive, which is this one. Here it's this one. The one which is difficult to derive here is this one. But this one, they made a mistake here. I think this is supposed to be positive. So we'll have that. And this one is difficult to derive. And here, this one is the one which is difficult to derive. Here it's this one. Here it's this one. Here it's this one. And here it's this one. Between tan and sec here it's this one. Reason I'm choosing tan here, even though you may think sine is the one which is difficult to derive. So when you derive tan x, you get sec squared x. So you can easily cancel sec. You see, right? So that one is like that. So you're going to write this. For the other 10, I won't give you a clue. Here I'm giving you a clue so you can, I don't want an excuse, right? I want to see these questions tomorrow. So you'll send them to me tomorrow in the form of a PDF. Tomorrow morning. Not necessarily morning, but I can say, so because you're going to have class, I'll say before the next class. I'm going to have to before, because we're having another class, I think around, let me check, 6:30 tomorrow. So I'll want to see this before 5. You'll send us a PDF. Before 5, you'll send us a PDF. All these 10, I'll give you another 10. So when it comes to integration by parts, they say that this integration technique is particularly useful for for integrating the product of two functions. The formula for integration by parts comes from product rule in differentiation. You see that? Now it comes to where we now want to reverse product rule. Now we say that Now we say that we're not going to use this, right? But I can also explain that. But this one is product rule. We know that if we have r is equal to gx times f of x, then for us to derive this, we keep one, derive the other, plus we keep the other one and derive the other one. You see, right? And then it's like that with product rule. Then when we come to this integration, remember that one said this. So we kept this one. Yeah, we kept f of x first. We derived g of x. We kept f of x plus, now we keep g of x and derive f of x. You see, right? Then now when we want to integrate, we'll just introduce integral dx on both sides, which is what they did here. You see that introduce here and introduce this side. Then we apply the integral on two equations. So when we apply the integral here, we also apply the integral here. You see, right? And this will be equal to, so when I come to apply this integral, we'll have that this is equal to, let's check this one first. The first one, which is g prime of x, x dx. Then for us to integrate this, we're going to keep the original function first. We keep the original function minus the integral of the opposite of this. You see, right? The opposite of that is gx times f prime of x dx. You see, right? And then we come, now we say that we know that if I integrate gx, I'm going to get g. If I integrate g prime of x, I'm going to get gx, right? So usually this, let's not write this for now. So now from this, it means that I can write this. I can take out this as a constant. I say that if I take out f of x as a constant, so let me erase this. If I take out f of x first as a constant and integrate gx, I want to get this. I want to show you how we get this. So that one is explaining this. You see, right now? It's just going to explain this. So if I say this, if I take out this as a constant and integrate this, then minus, here I come and say the integral of f prime of x. You see, right? Then the integral of gx dx. So in other words, I'm writing like this. Let me write here. So here it's the integral which this is equal to f of x, the integral of gx dx minus the integral dx. So now it's like we want to get back there, right? The integral dx. And then from the first try, we knew that we had f of x, right? But we're going to have integral of f of x. Then we had g prime of x. We're going to have its own integral dx. So we can, maybe let's write it on your page so you can understand. So we can write this on a new page. So remember this. Here, first we had r prime of x. Actually, let me say this. We're coming from the idea that r of x is equal to g of x times f of x. And if we apply product rule, we get this. Then now I can come and apply the integral on both sides. This will be the integral g prime of x f of x plus g of x f prime of x dx. And this will be, I distribute the integral on both sides. So if I want to focus on this will be for the integral of g prime of x f of x dx. This will be equal to, I would take these two functions, or I just come and say this will be, I take out f of x as a constant times the integral of g prime of x dx minus, I write the same thing here. Let me just write the same thing. I write this again. I want to show you something. So it's like this minus its integral. So it's like minus the integral of that, which is f of x integral g prime of x dx. I just put integral here. You see, right? It's that minus its integral. We agree, right? And this would be what? This would be f of x. Yeah, this one is prime. This one I would make that to be prime. Gx. That's the only thing you change there. Then minus, we know the integral of g prime x will be gx minus the integral of g prime x will be gx f prime of x gx dx. You see, right? So if I integrate this now, I can get the solution. So this is like saying this. It's like saying, there's that method also of saying the integral of u dv is equal to uv minus the integral of, you see here we have uv, u dv. Here we're going to interchange these two when we write there. We're just going to say v du. It's like here, check. This is the same thing here, we just represented this with small letters. Here I had g prime x, here I have gx. Here I had f of x, here I have f prime of x. It's like I just interchange those, I take the opposite. You see, right? I'm sure we all understand here. Do we get it? Anyone with a question? If you have a question, you can ask. So this would be integration by parts. I hope we see this. So if they wanted to prove integration by parts, this is what they would prefer you to write. So make sure you go look at this. I've explained how this happens, so make sure you go look at it. Make sure you go look at it. And then now we come to these functions. With this, we are no longer going to look at the difficult one to derive. We are going to use Liat. Say right now. So we are going to use Liat. Now we are going to say this. We are going to say that now, since we have since we have the integral of x e to the x, we ask ourselves, L stands for log, this for inverse, then algebra, trig, exponential. You see, right? So I'm just going to leave it like that here. Then first, the one that comes first, we're going to let it be u. You see, right? The one that comes first, we let it be u. So let's check which one comes first here. This one is algebra. This one is exponential. So the one that comes first is algebra, right? So we're going to let u be algebra and let e to the x be exponential. But that formula says this. Remember, the formula says that the integral of f of x g prime of x dx will be equals to f of x times g of x minus the integral. I take the opposite of this. You see, the opposite of that means that it will be what? It will be g of x f prime of x dx. You see, right? So what I can do first, so I can do this. Let me go there. Let me just take this question and show you. First, what I have to do, the one that comes first, we're going to let it be f of x. You see, right? Then let the one that comes first to be f of x. Then the second one will be just that e to the x, right? So we're going to say this. Yeah, I'm going to say this. Let me say this. The integral of x e to the x dx. I'm going to write this. I think the best way to explain it if I write it on a separate page. I have this, right? And the formula that I have is like this. It's saying the integral of f of x gx dx is equal to, then this I'll have, it says that I'll have first this is g prime of x, I'll have f of x outside, then the integral of g prime of x dx minus, I take the opposite of this, or I just come and say the integral of f prime of x, the integral of g prime of x. So here our f of x is gonna be the one that comes first in the art, which is x. You see, right? Then our g, the integral of g prime of x dx will be equal to the integral of e to the x dx, which is equal to e to the x. You see, right? And then if we have this, now I find, remember what I need here. I need what? I need f of x, I need f prime of x, I need g of x, I need g prime of x. You see, right? And we know that when we derive g prime of x, we get what? G of x. You see, right? But when I derive f of x, I get f prime of x. So this is going to be 1. So now I can go back to that formula, that this will imply that the integral of our f of x is what? Is x. Our g prime of x will be e to the x dx, which is equals to f of x is what? Is x. Then the derivative of that, the integral of g prime of x is e to the x, which is this, right? Minus the integral f prime of x is what? Is 1. I want to write 1. Then g prime, the integral of g prime of x, this one is this one, e to the x dx. This will be equals to x e to the x. If I integrate e to the x, I still get minus e to the x plus c. You see, right? Any question? So this requires practice. So the reason why I'm using this is also the run of UDV. I prefer not using it now. Reason being is because your guide is not using it. You said unless if we come across it here, then we can use it. But this one I feel like it's simple because the run of UDV, people usually make a lot of mistakes. So it's better if we use this one. You can see here, just like that. Then let's check this one. Now we have this one. It's e to the x sine x dx. Just gonna cut it. So now here I'm also gonna do the same thing. I write Liat. So this is trig, this is exponential, and trig comes first. You see, right? This is trig, this is exponential. This is algebra, this is exponential. So here I took algebra because it came first, right? Then here, the formula again, I'll say it. The only way you can understand this formula is if you write it multiple times, right? So that is by practicing. I have the integral of f of x g prime of x dx minus, I take f of x outside as a constant. So this is equal to f of x as a constant. Then I integrate g prime of x dx minus, now I take the opposite of this, right? Or I take this. I say the integral of f prime of x. So I'm just taking the integral and then I make this one to be f prime of x. Then I take this as it is. You see that? I can even copy it. Put the dx here to go with this one. You see, right? Then I know what I need. I need f of x, which is the one that came first, is sine. The one that comes first there, it's sine of x, which is trig. It came first. Then I'll just do this. It came first. Here, algebra came first. So I find f prime of x. I need f of x, I need f prime of x. F prime of x will be cos of x. Then I know that the integral of g prime of x dx will be the integral of the remaining days, what? E to the x. And e to the x dx remains the same. And that is our what? That is our gx. So I'm just gonna come back and plug here. So this will just be equals to, or this will imply that the integral f of x is what? Is sine x. The integral of g prime union is e to the x. And then dx. Yeah, this inside here is this, right? I have this. And then, which is good. Here you just write the original question so you don't confuse things, right? F of x, we know it's sine x. Then the integral of that is this. This integral is that. E to the x minus the integral f prime of x is what? Cos x. G, this one is this. E to the x. Then dx. Let's check something. We realize that this is not the same as this, and we can't easily integrate this because we still have the product of two functions. You see that? So it means that you must apply the same Liat approach. You must also come and say Liat. Tree comes first, still tree comes first. So I'm going to let f of x be cos of x. I derive it. I get minus sine of x. Then I have the integral of g prime of x dx, which will be equals to the integral of e to the x dx, which is still e to the x, which that is our g of x. Now I have this. You see, right? Now it means that I can come back and say this will imply the integral of sine x e to the x dx will be equals to sine x e to the x minus the integral of that. I'll apply that question. That question says this. It says that I have to write this. You see, f of x is what here? It's cos x. G prime of that is e to the x minus the integral. F prime of x is minus, this will become positive, sine x. Then g prime of that is e to the x dx, this one. You see, right? And then I close here. If we check here, I can just easily copy this to the other side. This will be minus. So this will be, I take this, you see this is the same as this. So I'll take it to the other side. This will imply, if I take it to the other side, this will become 2. The integral of sine x e to the x dx. This will be sine x e to the x minus cos x e to the x. Then I divide by 2. Integral of sine x e to the x dx, which is also sine e to the x minus cos x e to the x over 2 plus c. You see, right? Did I add c on that one when I was done? Oh, this one I was not, where is it? That one, yeah, plus c I did add. You see, right? Any question? So the best way to know this is if you do more practice, right? By parts. So let me see. We have the C. See, we only have one function, but if we use Liat, here we have two functions according to it, right? Which the function is 1 and ln x. One falls under algebra. So here we have algebra and lean. One falls under algebra. So log is lean, so it's the one which I'm gonna let it be f of x. You see, I have 1 and lean. So I let a1 be g prime of x. You see, right? So you can look at this one. See, so these are 8, right? It means that, I think for simplicity I can say this. I wanted to give you more questions on U substitution. What I can do, right, is this. On this one, since that one has 10 questions, this one is 8. It's 18, right? They need to be 28. So you'll submit tomorrow before 5. So what I'll do, I'll add another 5 here and 5 there. So that it will be like this. So what I can do, I'll give you a hint. According to Liat, I'll only underline the one that comes first. So let me write Liat here. I'll do you a favor so that you don't have to struggle, right? Then, but the other 5 I won't give you clue. So I prefer you start with these ones. So Liat, according to Liat, when I look at the first question, the one that comes first here, I have trig and exponential. I have algebra and exponential, so it's algebra that comes first. Then the second one, I have algebra and log, or take log, comes first. I have algebra and log, or take log. The algebra is 1. There, it's 1 times lean. You see, right? The fourth one, I have exponential and trig. Trig comes first. The fifth one, I have this one is it's not inverse, it's not algebra, it's not log, it's not exponential. It's x plus 1 over 2. So which one is simple to derive? I think here that they're all the same. You can choose any here. They're all algebra. So, but we can take this one as you can take this as u. And then sine. This is the inverse and algebra. One is algebra here. One is algebra. So you just take the inverse as u. Then t squared is algebra. Then t is lean. Take that as lean. Then sine t is trig and algebra. Here you just take this one as u. We have no choice. Sine lean u. You sine lean x. Trig and yeah. So you'll do this. So I think here, let me see. Yeah, you'll just take this. This one is a little bit intermediate since it's alone. So if you find something that is alone, you always take it as u. You see, right? So you'll do this one. I'll add extra 5 for this one type of a question. Then I also add the other type of a question. So this is. Yeah, so are we fine? So I think we can end the session here, right? So I don't have to give you a lot of work.